Hello everyone. Today we are talking about the counting sort. The counting sort is a sort technique based on the key between a specific range. It works by counting the number of objects having distinct key value, then doing some arithmetic to calculate the position of each object in the output sequence. Here are the general steps. The first step is counting number of each characters, then adding each number of its right number. Finally, move right by one position to get the start index of each character.
Let's look at how the counting sort actually work in a real example. Let's consider data in range of 0 to 7. We have an array which is 1302, 712. Right now, we can create a count array to store the count of each unique object. Our index will from 0 to 7, as our range is from 0 to 7. But initially, the counts will be all 0 because we haven't started to count. After we count, we can add the number into this array. Count each element in the given array and place the count as the appropriate index. Our goal is trying to make the original array from 1302, 712 to the output array. It should be in the order from small to large, which will be look like 0, 1, 1, 2, 2, 3, 7. The first step is to find the starting index of each number. We need to count the number of occurrence for each number in the array be our first step. Like in the original array, we have 0 appear 1 times, and 1 appear 2 times, 2 appear 2 times, and 3 appears 1 time. 4, 5, and 6 appear 0 times, 7 appear 1 times, and put the count into our count array. The next step is adding each number to the right of it. The first will still stay as the same, so that we can have the position of where the elements start, but that's not finished. We will have the counting array in 1, 3, 5, 6, 6, 6, 6, 7. Next step is going to be shift this whole array to the right by one position because the index will start from 0, so that we can find where the elements will start. After we move, we will have a new array which is 0, 1, 3, 5, 6, 6, 6, 6. This array is where the numbers start. Like for example, element 0 will start from the index 0, and element 2 will start from index 3. That also implies we only have 1 appear in 1 time, because 1 appear 2 times because there is index 1 and 2 for element 1. Finally, we got the array we want, which is 0, 1, 1, 2, 2, 3, 3, 7.
And for the understanding code part, the function of this code is to sort the count of each character in this page. And in this page, the first part of code is to change count I, so that count I now contains the actual position of this character in output array. The next part is to build the output character array. And the last part is to let array contain the output array. The first one is stable, and second one is this is a very straightforward sort algorithm. And the third one is time, which is the big O of n plus k. and the worst case and the best case is also the big O of n plus k. And the fifth one is angularity space for big O of n plus k. The n is the number of atoms that we have in the array, and the k is the range of numbers that we could have for each atom in the array. For the analysis, since the algorithm uses only simple for loops and it is straightforward to analyze, the initialization of the count array and the second for loop which performs a sum of elements on the count array. Each iterate at most k plus 1 times and therefore take big O of k time. The other two for loops and the initialization of the output array each take big O of n time. Therefore, the time for the whole algorithm is the sum of the times for these steps, which is big O of n plus k. So why CountingSort is stable? Since CountingSort can not only be used for sorting a list of integers, it can also be used for sorting a list of elements whose k is an integer. And these elements will be sorted by their keys while having additional information associated with each of them. That's all for the presentation of our groups for CountingSort. Thank you so much.